This example shows you how to compute the impedance of or equivalent resistance for infinite ladder circuit or network. So this infinite ladder circuit is shown. We want to find the equivalent resistor or impedance in this scenario, R equivalent. And then as you can see, things keep repeating forever. So we have R1 coming in series with the rest of the circuit, and then we have R2 and then R3, and then as you can see, starting from this point on, so let me just highlight it, starting from this point on, as you can see, starting from this point on, we have a repeat of the circuit happening on the right hand side of this dashed line. Effectively, you can say whatever happened to the right side of this dashed line is going to be a repeat of whatever we are seeing here. So since it goes forever, as you can see, this is going to happen uh, non-stop. So then we can say whatever you observe from this point on in terms of R equivalent is going to be the same R equivalent, the same unknown. Okay, so if that is the case, then things become easy. We can just say the equivalent resistor in this case, or impedance, is simply R1 in series plus, so it's plus R2 in parallel with the equivalent resistance, so R2 in parallel with uh, R equivalent. And then, of course, as you can see from this point, you have another R3 in series, so R3 in series. Okay, so what we can write then is the unknown R equivalent is equal to R1 plus, so R1 plus R3, these two guys. And then for the parallel of R2 and R equivalent, we can just simply write R2 times R equivalent divided by R2 plus R equivalent. Okay, and from this point on, it's just simply reshuffling things around. Let's multiply both sides of this equation with R2 plus R equivalent. So we end up with R equivalent times R2 plus R equivalent, which I can write it this way, squared, equal to, and then we have R1 plus R3 times R2, and finally we have R1 plus R3 times R equivalent, and the remaining component is R2 times R equivalent. Okay, so the nice thing is this cancels out with the other side, so this goes away with that, and whatever remains is going to be this outcome then. So as a result, what I'm getting is R equivalent squared, this component is equal, and then I can bring this guy to the left side, so I have R1 plus R3 times R equivalent, and I can do the same thing with this guy. I have minus R1 plus R3 times R2. Okay, so equal to 0. We got to something that is just a second order equation. We know that the roots of this, or the solution for this, would be R equivalent equal to simply minus B. So it would be R1 plus R3, the coefficient for R equivalent. Officially, mathematically, you would say plus minus. I'm going to show you that minus is not a valid solution here, because resistor or equivalent resistance should be a positive value, not a negative value, obviously, given that there is no active component in this circuit. It's all passive resistors, so the equivalent resistor should be a positive number, indication of a passive resistance. But under the square root, we have R1 plus R3 squared, and then we have simply 4 times this guy. So we have 4 times R1 plus R3 times R2. That's it. And then we have divide by 2 the whole thing. So we found the final solution. Let me change the color. So what we found here is, generally speaking, the equivalent resistance or impedance for this sort of infinite ladder network or circuit shown is equal to, if you want to, if you will, you can factor out R1 plus R3 like this, and then divide by 2. So what I did is I just factor out this component from both here and also from the whatever written under a square root, and factor out the 2, write it outside, and then times. We have 1. Now the minus is not a possible solution just because the value inside the square root is larger than the R1 plus R3 squared. So we cannot have a negative option here, because you will end up with an overall negative equivalent resistance, which is not acceptable, as I said, because it's a passive circuit. So we can only go with the plus. So um, negative is not the practical option. Negative, not acceptable, practically speaking. Okay, so that leaves us with simply 1 plus, and as I said, we factor out the R1 plus R3 squared from the under square root. So what leaves us would be 1 plus 4 R2 divided by R1 plus R3. All right, so this is the answer that we were looking for in terms of the overall equivalent resistance or impedance for uh, this infinite ladder circuit or network, as is shown here. I hope that you find this example helpful.